When a life ends, a completely different kind of story begins. It's one that's not told with words, but with biology. The body itself holds all these clues to its final moments, becoming this incredible biological clock. So, how in the world does forensic science actually learn to tell time on it? Let's dive in.
That's the fundamental question, right? For investigators who arrive at a scene, all the usual markers of time, they're just gone. The clock has literally stopped. So, where do you even begin to try and piece together a timeline?
Well, the answer is right there, in the body itself. It goes through this whole series of predictable, measurable changes after death. And by learning how to read those biological signals, investigators can essentially wind back the clock and figure out what happened and when. Okay, so our first major clue comes from the blood. And it's not just about what caused the death. It's about something else entirely. It's about where the body ended up. This whole phenomenon has a name. It's called Livor Mortis. It's pretty straightforward, really. Once the heart stops pumping, good old gravity just takes over. Blood starts to settle in whatever parts of the body are closest to the ground, and that creates this really distinct purplish-red color on the skin. And get this, it happens surprisingly fast. This pooling can start to show up in as little as 20 minutes, or up to 3 hours after death. That gives investigators a really crucial first anchor point in their timeline. And this is where it gets really clever. Okay, imagine a body is found lying on its back, but the blood has pooled on the stomach. What does that tell you? It tells investigators one thing for sure. The body was moved after death. It's like a silent witness that tells the real story of the scene. But it's really important to be precise here. Livor mortis is only about blood pooling because of gravity. It's not the same thing as the body stiffening, we're going to get to that in a second, and it's not caused by cells breaking down or any kind of toxin. Each of these clues tells its own specific part of the story. All right, on to our second clue, which is all about building out that timeline. This is probably the one you've seen in movies 100 times, but in the real world, its timing is absolutely everything. We are, of course, talking about rigor mortis, that temporary stiffening of the muscles. It follows this really predictable path. It starts, it hits its peak where the whole body is stiff, and then, and this is the critical part, it resolves. The muscles relax again, and that typically happens somewhere between 24 to 36 hours after death. That window, that's a huge piece of the puzzle. But here's the catch. Rigor mortis isn't some perfect stopwatch. There is one single external factor that can totally speed it up or slow it way, way down. And you guessed it, it's temperature. The whole relationship is actually pretty simple, but it's so critical. In a warm environment, all those chemical reactions that cause the stiffening, they just happen a lot faster. But in the cold, the whole process slows right down. So that means an investigator can't just look at the body, they have to factor in the temperature of the room or wherever they are to read this clue correctly. And that actually leads us perfectly into our third and final major clue. It also revolves around temperature, but in a totally different way. Think about it. A healthy, living person maintains a constant internal temperature, right? It's right around 37 degrees Celsius, or 98.6 Fahrenheit. That's our baseline. That's the starting point for this clock. So after death, the body's internal furnace, it just shuts off. It starts to lose heat, a process called Algor Mortis, and it keeps cooling down until it matches the temperature of its surroundings. So in a moderate environment, that might be around 21 degrees Celsius. And because this cooling happens at a roughly predictable rate, we're talking about 1 to 1.5 degrees per hour, just measuring the body's internal temperature gives investigators another really powerful tool to estimate how long it's been since that clock stopped ticking. So now we have our 3 major clues. We've got blood pooling, we have muscle stiffening, and we've got body temperature. The big question is, how do they all come together to tell the full story? Well, it's all about cross-referencing. Investigators never rely on just one sign. They use livor mortis to figure out the body's position, then they use rigor mortis to get a broad time window, and then they use the body temperature to narrow that estimate down even more. Each clue helps to confirm and refine the others. And in the end, it really comes down to this. The whole process is kind of like a form of translation, turning these purely biological signs into a human story. It's a quiet, methodical science, and it's all about giving a voice to those who can no longer speak for themselves. Which, of course, leaves us with one final fascinating question. When you think about all the variables, temperature, body fat, clothing, all of it, how certain can this science ever really be? Is it always about finding a single definitive answer? Or is it more about finding the best possible estimation? It really makes you think, doesn't it?